Okay, guys, I'm going to need some feedback from you if you don't remember this. Instead of, like in Algebra 2, we would do a whole day of, say, adding radicals. We would do a whole day of dividing, a whole day of multiplying. This is a hodgepodge of radicals to try to just bring it all back together. And I think this will be enough for us to remember how to do them all, okay? If you don't, let me know, and we can spend more time. So it says simplify the following radicals. Whenever we take a square root of a number, we try to eliminate any perfect square. The perfect squares are 1, 4, 9, 16, 25, 36, 49, 64, 81, 100. Do you know what comes after that? 121, 44, 169, 196, 225, and that's just from the multiplication tables up to 15, okay? So you don't have to necessarily commit all those to memory, but hopefully we know the first few, okay? And so when we take a square root, we just list the principal root, which is the positive root, okay? Because there are two numbers that multiply to 64. What are they? 8 and 8, but also -8 and -8. If we had a variable, x squared equals 64, and we square rooted, we would list two solutions. But because there's not a variable, we just list the principal root, which is, in this case, 8. And so that's it. But is there a integer solution to the square root of 28? Does it work out perfectly? No. So what we need to do is we need to remove the perfect square. So which one of these divide evenly into 28? 4 and 7. So I write it as the square root of 4 times the square root of 7. I always write the number that you can take the square root of first, and then the other number second. So what is the square root of 4? 2. Can you take the square root of 7? No. So I leave it as 2 roots of 7. And that is what we refer to as simplified, when you have removed any of the perfect squares. Rings a bell, right? There's another rule that we have regarding radicals, okay? I can't give you a real great reason why. I should probably research it, but you can't have a square root of a number in a denominator. Let's say you had 2 over the square root of x. You're allowed to have the square root of a variable in the denominator, but not a number. I can tell you why we allow that. I'm not sure exactly how this came about. But do you remember how we get rid of the square root in the denominator? Yeah, top and bottom by the root of 6. And so this just ends up being -5 roots of 6. What is the square root of 6 times the square root of 6? The square root of 36, which is 6. So that's what happens. The square root just goes away and we're left with 6. That's why it was so nice. Now sometimes we could simplify it from here. We would look at, say, those two numbers. Does -5 over 6 reduce at all? No. So the answer is just -5 roots of 6 over 6. It doesn't really simplify. So we've covered an example where there's an integer solution, one where we have to simplify. We've covered one where you divide. And now we're doing addition and subtraction. In addition and subtraction, what the radicand, or the number underneath the square root sign, has to be the same. So square root of 27, square root of 48, I can't do that subtraction yet. But maybe if I simplify them, maybe it will work out. What is a perfect square that divides evenly into 27? Yeah, so I have 2 times the root of 9 times the root of 3 minus 4 times. Is there a perfect square that divides evenly into 48? $16 goes into 48 3 times. That's a tough one. That's why I put it up here. But so 16 does work, okay? So we have the root of 16, the root of 3. What is the root of 3, or root of 9? And so it's 3 times 2 is 6. So this becomes 6 roots of 3 minus square root of 16 is times 4. So I have 16 roots of 3. Are the radicands the same now? Yeah, so now you can do the subtraction. This is kind of like 6x minus 16x. Okay, instead of an x, I have the root of 3. So what's 6 minus 16? Negative 10 roots of 3. Very good. So we've done an example of addition, subtraction, division. We're going to continue to try 4 more here and see how they go. Yes, the nice thing is with multiplication is that we could just multiply them together and then simplify from there. So when you multiply, we're going to multiply the coefficients. So 3 times negative 2 is negative 6. And then we multiply the radicands. You can multiply. Can't add them, but you can multiply. So 5 times 12 is 60. Now the question is, can you simplify or reduce the square root of 60? Is there a perfect square that divides evenly into 60? 10 goes in 6 times, but neither 10 is a perfect square, nor is 6 a perfect square. What number goes in 4 times into 60? 15. Yeah, it's like a clock, right? 4 sections of 15 on the clock, right? So part of it is just getting used to the number sense. Otherwise, what you have to do is you just have to take your calculator and go back and divide them. So, it's 60 divided by 49 doesn't work. 36, 25, 16, 9, but it does work by 4. Another way I know that 60 is divisible by 4? I take 60 and divide it by 2, and I get 30. I divide it by 2 again, I get 15. So that means that it was divisible by 4 if it's divisible by 2 twice. Yeah. Some people make the factor trees. It's another way to do it. So there's ways kind of around that. So anyway, so there you go. So we have that. So the square root of 4 is 2 times negative 6 is going to give me negative 12 roots of 15. Okay, we've got D. What's wrong with this? What do I have to get rid of? Yep, I can't have the square root of 6, so I multiply top and bottom by square root of 6. Okay, I can multiply radicals. Square root of 20 times square root of 6. What's 20 times 6? 120 over just 6. Now I have to think of what 120 is divisible by. And sometimes I just, that's a big number, and I just try for maybe one of the smaller ones. So is it divisible by 4? Can you divide by 2 twice? Yeah. So we'll do 4. Let's see what divide by 4 would give me 30. So I have the square root of 4 times the square root of 30 over 6. What's the square root of 4? 2. So I have 2 roots of 30 over 6. Now, is there a perfect square that divides evenly into 30? No, there isn't. So 30 is done. But can you simplify 2 over 6? 1 over 3. So you don't have to write the 1. You just write the square root of 30 over 3. In trigonometry, you guys, you're not going to deal with a lot of square roots that way, but I will say without a doubt, you have to be able to do this. Say you have 2 over the root of 3. Could you write that as 2 times the root of 3 over 3 by multiplying the top and bottom by the root of 3? That's probably the most common thing that we do, okay? So kind of like how we multiply top and by the root of 6, here you can multiply top and bottom by the root of 3. And so those are the pieces that we'll do moving forward. So our review of radicals is probably a little bit more than what we have to see, but I want you to see these for good practice. Okay, we'll look at F. We want to add them, so what numbers have to be the same? Yep, the numbers underneath the square root. So they're not the same, so I'll try to reduce them first. Perfect square divides evenly into 44. Yep, 11 and 4. So I got the square root of 4 times square root of 11 plus 3 times, what's the perfect square divides evenly into 99? 9 times 11. What's that? No, because 3 and 33, neither one of those is a perfect square, but 9 is. So one of them has to be a perfect square. Square root of 4, I have 2 roots of 11 plus square root of 9. 3 times 3 is 9 root of 11. Can I add them together now? And we get a total of 11 roots of 11. Try a big one. Square root of 242. If you look here, I like to often pick where 242 would lie. It would be right here. And so it's, you could just start dividing backwards. But do you catch which one it's divisible by? 121. How many times does it go in there? Twice. Yeah, so, you won't have a lot of times where you see that, but just for some extra practice, why don't you see, you can do square root of 121 times the square root of 2. What's the square root of 121? So it's 11 roots of 2. And that's why I put it up there. So here's another tough one. We'll see if you see this. Square root of 80. Do you know what number divides evenly into 80? That's a perfect square. 4 does go in, and so you could go square root of 4 times the square root of 20. You get 2 roots of 20, but then you can reduce 20, right? 5 and 4 again. So you have 2 roots of 4, roots of 5, so you get 4 roots of 5. Well, you could also write it as 16 is the number that goes in 5 times. So there are some ones that are tough out there to see. Try to get some practice and, just do our best. So today's assignment will be a review of radicals. It's a worksheet. And I want you guys to know I've modified a lot of things from first semester. So if I saw students struggling with things first semester, I tried to make the changes so that we would get the right practice with it. And the fact is that the book doesn't really have the problems that I like to cover on this. So we'll do this last example, number 5. Sorry, we're going to do order of operations and the radicals. So that'll be a piece. Short review of order of operations. What is the order of operations? We start with parentheses, then multiplication and division are on the same level, okay? And addition and subtraction are on the same level. It's whatever comes first, left to right. So let's just do these together. Which operation do I do first? 16 minus 10 divided by 2 plus 3. What might somebody be tempted to do that they should not do right now? 16 minus 10. Yep. But what do you have to do first? Yes. So 16 minus 5 plus 3. Do I add first or do I subtract first? Subtract, because they're on the same level, just whichever comes first, left to right. How many times did somebody tell you that addition is before subtraction? I know that we've had a number of times where we've had people who have mistaught that at earlier ages, okay? But the order of operation is 16 minus 5 is 11, plus 3 is 14. I want you guys to be prepared that you might get an order of operation problem wrong. Because in my college algebra class, I get plenty of people who get them wrong. So you just go through it a little bit too quickly. So when I first look at it, I'm like, oh, 5. 10 divided by 5 is 2. And and then I go, you can't do that. That's okay, so it did work in that situation. That's just by chance. It shouldn't work out like that. It shouldn't work out like that. Okay, what do I do first in B? Yeah, because parentheses are part of a square root. Square root's a grouping symbol, so it's like parentheses. So I do that 4 times 5. 20 minus the square root of 5 plus, what's 4 times 5? 20. 20 minus 5 plus 20 is 25. Can I now take the square root? 20 minus 5 is 15. Good. Absolute values are also like parentheses, and so are division symbols. So you're going to do the top separate from the bottom. So what should I do first in the top? Yep, so minus 3 minus 6 is, if you want to just do the bottom right now, you sure can. So we did it separately. The absolute value of negative 3, 3, so I have 10 minus 3 over 7. 7 over 7 is 1. In your assignment, I can't guarantee that they all come up to be integers. How about D? Which part do you do first? Yeah, the inmost parentheses. So 15 minus 8 plus 6 minus 2. Now I go again. 15 minus 8 plus 4. 15 minus, now evaluate 3. Why don't you quick try to do the last two on your own? All right, the answer's up for you to check them. You should come up with 14. You should put 3. So, all right, that said, tomorrow we will move on to, you guys got the order of operations. We'll just skip those. Maybe we'll do this checkpoint tomorrow. Tomorrow we'll get into kind of these algebraic expressions. This is where a lot of mistakes tend to be made, is when do we add exponents, when we multiply them, stuff like that. And so once we get done with that, then you should feel good to go. So a nice review. So I'll hand out your assignment.